to one more presentation on SCADA. So in our previous presentation we have seen what are the different contents that we are supposed to look in, and after that we have seen some brief introduction about the SCADA, why the SCADA is required. Then moving ahead, we have seen some of the fundamental principles of modern SCADA system, how the conventional systems are different, the older versions, the compartmentalized operation, standalone systems, how they have come to systems with standard hardware and software platforms. So those things we have seen, right? And what exactly is the principle of working of the modern SCADA system, that also we have seen in our previous presentation. And after that, two types of definitions as long as the SCADA system is concerned, right? From the two important references, how exactly a SCADA system is defined, that we have seen both from the point of view of one standard textbook and even IEEE standard C3.37.1 which was given in 1994. So after that we have seen some of the major functions that your SCADA system is supposed to carry out, specifically with respect to the power system operation. Then the design, why the SCADA design requirement is there, and what are the benefits, right? Where exactly we are going to use the SCADA system design, that also we have seen, right? Then what is being controlled using the SCADA, especially again from the point of view of the electrical power system, right? The tap changes, switching of the shunt or shunt capacitor or reactors, set points of the generators, the governor control, excitation control, the power outputs, and the different type of sequential controls, that also we have seen. And we have seen one block diagram with respect to the typical SCADA system, what exactly it contains, the typical SCADA system. And finally, I think somewhere here we had stopped with the hardware architecture of a SCADA system. So with this thing as the background, let us move ahead now, quickly look into some of the historical issues or the developments which have taken place in the SCADA system. And as I've already made a mention earlier, right? So with the advent in the semiconductor technology, right? So early 70s. So we call them as the distributed control systems, DCS, distributed control systems, were developed to control separate remote substations. And in 80s, with the development of your microcomputers, process control could be distributed among the remote site. So initially it was the distributed control was confined to a particular system, but later it was extended to the process control, where you could have the communication channels and other things coming into picture, and even the high level computing and other things were possible, because of which it was possible to have the distribution among the different remote sites. Okay, then the further development enabled the distributed control systems to use PLCs, right? So this is where we have to see some of the comparisons, right? What exactly is the comparison or the similarities and dissimilarities between the PLCs and SCADA. Later we will see that, right? And here basically without going into the directions from a master, so the programmable logic control, they themselves started behaving as the masters, because they have got the programming ability, they have got the logical abilities, and they have got the control abilities, because of which a central controller was not found essential, and the PLCs could do that work of a central master, or taking the directions from the master. This is how the history evolved, right? And moving ahead, anyway, this we will not take. This is the 60s. In the late 90s, the SCADA systems were built with the DCS capabilities, and systems were customized based on certain proprietary control features built in the designer, right? So additional features started getting developed into these systems, ultimately aiming at better control, flexibility in the control, or even the reliability in the overall the operation, right from acquiring the data, then supervision, right, and finally the control, right? Now, as of now, what you can see is the different types of the internet based controls and other things have come into picture. So that's the reason why, with the internet being used, right, more as a communication tool, the SCADA and telemetry systems are using automated software, right, with certain portals to download information or the control a process. Some examples I will take later, right, how exactly the automated softwares play their role in the overall the data acquisition system, even in the supervisory control. So then engineered SCADA today not only control processes, but also are used for measuring, forecasting, building, analyzing, and planning, right? So now it is not only left for the purpose of only controlling, and apart from that, the different ancillary services like measurement, forecasting, billing. So forecasting means now the ANN techniques, the artificial neural network techniques, or even some other kind of techniques. I am speaking typically from the point of view of the electrical scenario, right? So it could be billing, it could be analyzing, it could be planning. So when we say about these analyzing and planning, so definitely our IoT based systems will come into picture. We have already seen that. Okay, so now with these things, it is possible for us to make your SCADA system not only confined only for the controlling, but all the different associated ancillary services, right? Today's SCADA system must meet a whole new level of control automation while interfacing with yesterday's obsolete equipment, yet remain flexible enough to adopt tomorrow's development. So basically, whatever we have now, right, so they should be used in such a way that whatever we feel that they are obsolete, that is the old equipment, they also can be used effectively, so that our next futuristic demands are met. So this is what is the meaning here. Then moving ahead, we have the SCADA early system, how the early systems were perceived, right? So definitely the systems were connected by virtue of the wires, right? The wires required for each devices between the control point and control devices. So definitely, because of which the cost and complexity, right, was very high, especially when the number of devices are required to be remotely controlled and supervised, right? High cost even because of the long distances, right, between the different masters and slaves, the central control unit and the different units which were supposed to be controlled. So the distance if increases, definitely because of the wired connection, the overall system cost would increase. Reliability suffered due to electrical noise induced in the control unit. So this is one advantage even we have seen in the case of PLC systems, right? So they are mostly they are independent of the electrical noises and the interferences, right, which are due to a kind of electromagnetic signals and all, right? So therefore, whenever you have these signals superimposed with your data, so probably many a times the data would have been misread or it would have been misinterpreted. All these problems were common. So ultimately, for a better control of the system, you would always wish to have the accurate data. As long as your data is accurate, then definitely you would have the system control also accurately. So if that doesn't happen because of whatever the technological loopholes we have in the overall system, then definitely the controllability is also not accurate. So this particular problem was very much, especially in the earlier the systems, right? Wire circuits can minimize by use of selective relays, but some became complex and difficult to maintain, limited in speed and operation. So basically here it is being spoken about the difficulties or the limitations of the wired circuits which were used in the early days, right? So now in contrast to the earlier days SCADA system, nowadays, right, what we have in the modern system, you have got the computerized based system. Master units consist of digital computer with IO equipment, transmit control message to the remote units, receive information, display on CRT and printed on electronic printers, graphical info, online diagrams, wall diagrams. These are all the new terminologies which were not used earlier days. Especially here you have the wireless communication. This is one basic advantage, right, compared to the wired communication. Nowadays, after having gone through a course on IoT, you definitely appreciate in what way these modern systems, right, can be helpful, especially keeping in view of enhancing the system reliability, accuracy, as well as the operation speed, right? So all these things are very much essential, especially you want to have a better controllability. So this is what we call as the SCADA of modern system, and of course the SCADA evolution, right? So the evolution of the SCADA, many things are repeated here. I'm not going into these details, right? So how the programmable logic controls came into a picture, right? The ladder logic, right? So how the ladder logic came into existence, right? So the PLCs appealed to the traditional control engineers who were accustomed to programming relay logic and who did not want to learn programming languages and operating systems. So this is where this particular sentence is what can tell you about the significance of the PLCs, right? So the people who do not wish to learn high level programming languages, but at the same time they are not happy with the relay control, so probably the PLC is an ideal choice for those kind of people, right? You have the programmable control as well as the programming technique compared to the other type of programming techniques became relatively simple. So that is the reason why in many of the SCADA systems, so PLCs have become one major ingredient, right? So which were used to take the data, or which were basically used as the interface between your the industrial scenario and the master control unit which was on the other side. Probably when we take up that diagram later, so you would come to know how the PLCs are significant in the overall SCADA system. So like that you have some other things, right? Microcomputers were developed, they were programmed and packaged to emulate PLCs in the functions, programming and operation, right? So initially this I have already told you, right? The distributed control system was confined to a particular plant, then it was extended to the different terminals. The early control systems consists of a central mini computer or PLC that communicated with local controllers that interface with the motors, pumps, valves, switches, sensors and other things. So this was the typical scenario earlier, but as the technology developed, right, so you can definitely see, or you can understand in what way the overall system got changed, right? So the DCS is generally confined to the locations close to each other, normally use a high speed local network and usually involve closed loop control. So this is what you can see in this particular system. You have got a microcomputer or a mini computer or the PLC, you have got the PLCs or PLC controllers, and these are the valves, pumps, motors and other things which are being controlled by those things. Now when you have everything connected here, so from a central system it would be easier for you to look into these data and accordingly control these end devices. Could it be a valve, or could it be a pump, could it be a motor or something like that, right? So this is how the basic DCS, the distributed control system, give a thought for the engineers then to go with a modernized system, which finally led to the concept of SCADA. As the technical capabilities of the computers, operating systems, and networks improved, the organization management pushed for increased knowledge and the real-time status of the plant operations. So this is a very, very important real-time status of the plant operations, right? So how would you get the real-time status? You should have sufficient infrastructure to do that. At the same time, the communication channel should be available. So in spite of that, right, so if you don't have the proper resources at your processing stations, then even if you have the proper communication channels and the acquisition methods, then your system would not be complete, right? So therefore, whenever you want to have the real time status of the plant operation, all these things are very essential, right? So in organizations with a number of geographically separated operations, so you have a big system, right? So the different you can just think of a factory, a mega factory, right? So could it be a sugar factory, could it be a cement factory? There are different kinds of operations which are segregated to different blocks or different sections. The coordination among all these operations have to be done, and the SCADA probably is one of the better solutions in order to have the coordinated operations within a premises, but with the different sections or the different blocks, right? The organizations with a number of geographically separated operations, remote data acquisition, this is very important, control and maintenance became increasingly attractive for from the management and cost standpoints. So definitely, ultimately, so you should have ease of control. That's where your management comes into picture. At the same time, the ease of control should be with lesser cost. That's where your cost standpoint comes into picture. So now all these capabilities, so getting the real-time data, right? So remote data acquisition, control, maintenance, right? So all these things are collectively known as supervisory control and data acquisition. So again, this will reflect to the the definition initially whatever we have taken for the SCADA, but there maybe in some context, so your MTU will come into picture or RTU will come into picture. They are just the references to just mention the distance, control and other things in the other nomenclatures, right? So all these capabilities are known collectively as supervisory control and data acquisition, or SCADA. So this is how the SCADA evolution has taken place. Now let us try to look into a typical SCADA architecture, right? So this is very important from the point of view of even examination also. Let us quickly look into the architectural point of view of the SCADA. So now basically you have some field data. Let me draw this diagram. You can just have the diagram on your own also. That is the reason why I have not taken this diagram which is already there. So I expect you to draw this parallelly along with me. So this is one block where you have the field data. Okay, anyway, I just draw this. I first complete this, so later we can so here I have one block here. You can take it. I just draw it roughly because I don't have my a proctor with me right now. So anyway, that should not be a problem. You can take it like this. Then you have one more here, one more channel, something like this. Please note down these things very carefully and properly. So you have got one more block here, something like this. Then you have one more channel here, like this. Again, this is also a communication channel. Then from here you have one more here. This is where your operator comes into picture. It will be something like this. Please note down this. So this is where you have your operator. One second. So this is what is your operator. So I'm having some problem with the color here. Anyway, let us look into these things now. Yeah, this is the operator. Then here you have this is a field data element. This is field data element, right? Then you have here the next one. This is the field data acquisition and control unit. Please note down these things: field data acquisition and control unit, this one. And then we have the central control station here. So this is the central control station. I hope you are all drawing properly these things. This is also called as MTU. Master Terminal Unit. Then you have here HMI. You know what is the meaning of HMI. I will write in the bracket: human machine interface. HMI stands for human machine interface. Then you have the operator here. We have already written it here. And here basically whenever you speak about the field data, right, we have already written it here. So anyway, I will just take it here, and this is basically, here I will write in, it could be, you know, pump, it could be, you know, a sensor, right, or it could be a switch, anything here, right. So generally this here, whatever the channel we have, right, so this is a high data rate. Generally it is closed loop control. Here I will explain all these things. First I will write these things. So this is closed loop control here. Then here this one is relatively slow. Generally it is open loop system. Here you have got the open loop system here, relatively slow. And this is what is the communication here. This is what is, the communication. This is the communication channel that you have, and we have already written the central control station, the human machine interface, right? So here this this could be either a remote terminal unit, RTU, or it could be a PLC, something like that, this one. So now I think the diagram is fully clear, right? So you can take these as the bidirectional lines as I have drawn here. May not be very clear, but still you should be able to understand what exactly I have written here. So this is what is a very important, the architecture of the SCADA system, right? So far we have seen what exactly is a SCADA system: supervisory control and data acquisition. So whenever you want to have the supervision over a system, first you will have to have the data. After having had the data, you will have to have the acquisition of the data. You know how exactly the data is acquired after having gone through a course on Internet of Things. You know, the physical layer, data link layer, network layer, then the higher level layers. So how would they act in order to have the gathering of the information, measuring the information, gathering the data, then you have to have them in the proper format, enrichment, right, consolidation of the data. So after consolidation, you pass the data to the different higher layers where the different kinds of processes take place, and with those processes finally the analysis of the data takes place, then the action on that particular data takes place. Basically they are aimed at your business intelligence and other things. But here, though the procedure remains almost similar, but this is done for a different purpose, right? So therefore keeping those things at the back of your mind, so probably you should be able to understand how exactly the SCADA architecture can be had here, right? So we here when we speak about the field data here, basically, so it need not be only one, right? You can have the multiple blocks here, something like that. This is another, this is another. Here also you can have the multiple blocks. Here also you can have the multiple blocks. You need not have only okay, as long as the central control station is concerned, it will be a single, right? But as long as the field data acquisition and control is concerned, or basic field data elements are concerned, you can definitely have a cluster of blocks there. It could be a pump, sensor, switch, or any kind of the physical layer device which gives you the data, right? Then from there you will go to its next state, wherein you have the data. Sorry, this is not file, it is a field. One second, here we need to have a small change. It has become file here, it is field. Okay, it is field data acquisition and control. Now see here, from the field data element and the RTU, you would always have a high speed communication because it's a closed loop system. It has got a very high rate, right? So as soon as the pumps or sensors or switches they take the basic data, the acquisition of the data for passing it on to higher level, it takes place with a very high rate. Anyway, I will explain all those things in your next slides also. Then you have got the communication, right? Compared to this, okay, here it is relatively slow, right? Because it's an open loop system, and this communication, this happens. So as long as the communication is concerned, you may have here, as here basically you may have the internet, right? So you may have the wireless network, you may have the wireless network, right? So or you may have the public networks, public telephone networks, one second, a wireless network, or you may have public telephone networks, right? So you can have anything as long as the communication is concerned here. So then it goes to central control station, MTU, right? So master terminal unit. Then you may have the human machine interface. We have already seen this in our diagram earlier, the block diagram, right? So then you will have an operator. So the operator will take care of the manual operations, right? So which are required to have the display at different locations, as we have already seen, right? Or you know, to have their own way of communication with their neighboring you know, branches or neighboring entities and all, right? So this is how the things look in a overall picture, right? As long as the SCADA architecture is concerned, right? You have got the field data element, you have got you know, the field data acquisition and control unit, which is also called as remote terminal unit. Could it be the PLC, right? Then you have got the communication channel, you have got the central control station, right, the MTU, then your human machine interface or the operator on the other side. Now if you keep this diagram at the back of your mind, so you can just see here, right? So what exactly are the individual tasks of each components there, specific terminologies associated with the components of the SCADA system. The first one, right, I am starting from the top here, right? The first one, the operator, right? Human operator who monitors the SCADA system and performs the supervisory control functions for the remote plant operation. Then you have got HMI, human machine interface, presents data to the operator and provides for the control input in a variety of formats, including graphics, right? It could be schematics, it could be pull down menus, right? Touch screens, it could be windows, the different things. So this is where you have the human machine interface. Sometimes you have you know, the data of the power being consumed in a particular day, in a particular section, right? So how exactly it can be represented? It can be represented in the tabular format, right? It could be represented in the graphical format, right? It could be represented in the schematics, right? Suppose now you have got a solar power station installed. So from morning to evening, what is the pattern of the energy generation? What is the pattern of irradiance, right? So is there any cloud coming? So how quickly the irradiance goes down and how it will affect on the power production, all these things. Suppose if you visit our LDC here, which is located in the HESCOM office, right? So probably you will come to know, right, how exactly this data acquisition and other things are being done there, right? So based on which they take different kinds of action, right? So whenever there is less production due to whatever may be the reason, right? So ultimately they may you know, shut down some of the loads or something like that, right? It's totally a closed loop control, right? So human machine interface basically presents the data to the operator and provides for the control input in a variety of formats like graphics, schematics, windows, pull down menus, touch screens and other things, right? Then you have got the master terminal unit. I have already spoken about this. The master terminal unit equivalent to master unit in a master slave architecture. So probably that speaks what exactly your MTU is. It is like a master in the master slave architecture. The MTU presents the data to the operator through the HMI. You can see here MTU presents the data to the operator through the HMI, human machine interface, right? Gathers the data from distant site and transmits control signal to the remote site, right? So now you gather the data here, right? Then it will transmit. Anyway, that particular thing is not shown here, right? You can definitely take something like this. It transmits the information, right? Whatever it has got, the control signals to the remote site. So then you have got the communication channels, right? Communication method between MTU and remote controllers. Communication can be through the internet, wireless or wired network, or even the public telephone networks, right? Then you have got the remote terminal unit. So this remote terminal unit is functioning as a slave in the master slave architecture. So now this master terminal unit and the remote terminal unit, you exactly know what is their functions, right? It functions as the slave in the master slave architecture, sends the control signal to the device under control, acquires the data from these devices, and its duty is to transfer it to the MTU. This is how the things take place in a SCADA architecture, as long as the different components are concerned, right? So now this is basically slave here, and this is the master, right? If you take the master control, master slave analogy, right? So basically this slave, it will take the instructions from the master, functions as a slave, sends the control signal to the device under control, acquires the data from these devices, and transmits the data. Now here one thing you should understand, whenever we speak about the the SCADA system, the basic fetching of the information plays a very crucial role, and this is possible now for with such a highest degree of success only because of the modern day sensors, right? Especially in the power system. So you have got so many sensors which are even smart sensors. You know what are the smart sensors. So finally the success of the entire system in a closed loop control, it depends upon how best you fetch the data, how accurately you fetch the data. But not only fetching the data, and the data should be in the presentable format. Once the data is in the presentable format, you have the other things automatically being controlled in a appropriate manner. Okay, so these are some of the important components, right? So anyway, if you look at the remote terminal unit, its specifications, right? Small sized RTUs generally have less than 10 to 20 analog and digital signal. Mediums have about 100 digital and 30 to 40 analog inputs. RTUs having a capacity larger than these, that is the small sized or medium sized, they are classified as the large RTUs, right? So maybe more than 100 digital channels, more than 50 analog inputs. So they are called as the large remote terminal units, and depending upon the system complexity, you would use the large remote terminal units, right? So if you in the power systems, especially because the power system is a very complicated network, so probably even a part of a system could use a large RTU, remote terminal unit. Okay, so now if you look at this diagram, so probably it will give you an idea about what exactly your RTU, right? So you have got the power supply, you have got the central processing unit, right? So you have got the different kinds of the memories here, right? You have got the analog input module, analog output module, you have got the digital input module, you have got the digital output module, the bus system. I am not going into any kind of the details here, because after having gone through your microcontroller system, right, so you know everything what exactly this means. Okay, and you may have a modem here, modulator and demodulator, right? And you have got a radio receiver and transmitter, and through this antenna the information can be sent to your master control unit, right? I mean the master terminal unit which you have seen, right? Then you can have the serial communication ports for your the other side requirement, because your RTU, if you look at the RTU, one side it will go to your MTU, right, and another side it will go to you its basic sensors or the basic sensing mechanisms whatever you have, right? So that is done by virtue of your the basic interfaces like your RS-232 ports, right, serial communication ports, and you may have a PLC as it is. This is very important. That is the reason why there it is given as RTU PLC. RTU PLC, right? So a PLC may also be one of the important parts which will directly give the information to your central processing unit of your RTU. Sometimes togetherly these things are conceived, the RTU and PLC. So basically the task here is to get the information, get the command from your MTU, then send the signal to its basic units, gather the information, right? So after having gathered the information, based on its memory capacity or based on its ability to process those data logically, right? So send those information to MTU. That's what is the function of your RTU here. Okay. So now here you can once again quickly look at the main RTU. It has got the power supply, then all other informations here, that is your CPU, the memory, whether it is volatile or non-volatile, RAM or ROM, right? Then the analog modules, the digital modules, right? Then the different communication ports, the modems, receivers, then sending the information to your MTU. They can be seen in a single block. This is what is the block diagram of your RTU. Okay. So based on these things, right, whatever we have seen the architecture, so generally we have got three types of classifications as long as the SCADA architecture is concerned, right? The first generation, the second generation and the third generation. You can see here the first generation refers to the monolithic, the second generation refers to the distributed, and the third generation refers to the network type. So definitely the first one is the most crudest one, the simple one. Then this is an advanced or enhanced version of the first generation, and nowadays whatever we are having the third generation. Maybe the fourth one that is not mentioned here, that is also there, that is called as IoT based SCADA. Nowadays this is playing a very, very important role after the advancements in the Internet of Things technology. The fourth one, right? These are the four types of the architectures that we have in our the SCADA system, and each type of these we shall probably see in our next presentation. So far whatever we have discussed is about the history, okay, the history of the SCADA system, SCADA history, then what was the early SCADA system, what is the modern SCADA system, how exactly the evolution of the SCADA system has taken place, which goes in parallel with the history which we have taken, right? So then we have the very important one, the SCADA architecture, right? So how exactly you can conceive or can see the SCADA architecture, what do you mean by MTU, what do you mean by RTU, then what do you mean by HMI, human machine interface, what is the role of the operator, right? So what exactly you mean by the field data elements, the explanation of all those things we have seen. And after that we have seen the classification in the RTU, the medium, small, medium and the large, depending upon the availability of the input and output channels, the number of input and output channels. Then we have seen a typical diagram of the block diagram of the RTU, how exactly an RTU can be seen, right? So then from there we have gone ahead with the SCADA architecture, right? So the classifications in the SCADA architecture, right from the first generation, then second generation, third generation, which is running as on today, the network based generation, and beyond that we have got the IoT based SCADA system. So the explanation of all these things, the general discussion on these things, right, what exactly they are, everything probably we will see in our next presentation. So with this I think I will stop here. We shall meet again in our next presentation for the subsequent aspects related to the SCADA.